Hey everyone, good evening. Today in Tech Nexus, we will be discussing and demonstrating our implementation for automated medical questionnaire with Twilio and ChatGPT. So I am Mayuraj Devangan, working as a software engineer at Mindbowser.
And I'm Akshay Tiwari, working as an associate software engineer in Mindbowser. So today we are going to explore how automation and AI can transform the way medical questionnaires are conducted with advancement in healthcare technology. We can now streamline patient interaction using Twilio for seamless communication and ChatGPT for intelligent response. The solution which we are bringing today basically enables healthcare providers to automate patient intakes, symptom assumption, and follow-ups, enhancing efficiency, reducing patient workload, and improving healthcare and patient experience. In this presentation, we'll walk through how Twilio facilitates real-time messaging and voice interaction, how ChatGPT intelligently processes patient response and respond accordingly, and how automation improve accuracy and efficiency in healthcare domain. So why we need to automate medical questionnaires? The first and very basic thing is efficiency. Automating patient intake reduces the time healthcare providers spend on manual data entry and also the accuracy which can prevent the human errors. Now the second question comes: how Twilio and ChatGPT fit into this? First of all, Twilio handles the communication layers, enabling automated phone calls, and ChatGPT processes the natural language response from patient, ensuring the symptom system understand and validates patient inputs accurately. So uh, we uh, we are using Metplum as an tool to uh, tool to fit our Metplum questionnaires as a FHIR resource so that we can deal with it. So today's agendas are Metplum overview, Twilio and ChatGPT overview, setting up AWS Lambda, etc., etc. So as I already introduced you about the medical questionnaires and how we are going to enhance the experience of the patients and healthcare providers, reducing their times and efforts into which they are taking like huge time to go through it. So what is Metplum? Metplum is an headless EHR system, meaning it provides backend functionality without a built-in user interface, allowing developers to build custom front-end and more. It is the most important thing about Metplum is it is FHIR compliant also as well as HIPAA compliant. Metplum adheres the FHIR, which is Fast Healthcare Interoperability Resource Standard, which is a modern framework for exchanging healthcare data. This ensures the data is stored in Metplum can be easily shared with other FHIR compliant systems like Epic, Cerner, Veradim, etc. Metplum also support Lambda-based bots, which uses AWS Lambda to run serverless function that automates tasks. For example, if you create a bot that automatically processes the patient data and send reminder or trigger notification based on your condition or what you code, the code have you written on those bots. Why we are using Metplum? It is easy to set up. It provides REST API, scalability, and security. Metplum ensures data is encrypted both in transit and at rest, complying with healthcare regulations like HIPAA, as I already mentioned. One of the most important which Metplum provides is FHIR resources, which is the like root of the USA healthcare system. If we don't use Metplum, it will be a really complex process to verify like the FHIR resources which we are storing in the Metplum is correct or not. So Metplum help us and enhances our experience to deal with FHIR resources. So let's talk about the Metplum architecture. As we can see in the picture, high level overview of Metplum architecture, which is built on AWS services. So what it deals with is AWS cloud infrastructure, which has VPC, which is virtual private cloud. Then there is a ECS, Elastic Container Services, which runs its production web service on ECS, which allows it to manage and scale containerized application efficiently. It has RDS PostgreSQL, which Metplum uses to store its data on Postgres. Basically, it uses relational database system. RDS also provides automated backups, patching, and scaling, ensuring high availability and durability. Then there is Elastic Cache, Metplum, which uses Elastic Cache for caching frequently accessed data, reducing the latency and improves the performance. Then there is Lambda, which is the most important part of the Metplum. Metplum uses AWS Lambda for event-driven automation. For example, let's take an example. When a new patient record is created, a Lambda function can automatically trigger the notification or update related record. Then there is the S3, AWS S3, which is used for the storage services for user-generated content such as medical image, document, and questionnaires, and many other things. S3 ensures that data is encrypted both in transit and rest, providing a secure storage solution for our data to store. Then the last part is CloudFront. Metcom uses CloudFront, which is a content delivery network, which we also call as CDN, to securely deliver content to user with low latency. This is especially important for delivering large files like medical images or videos, which is highly required in the medical field. Then comes the question, what about the security? Metplum is providing so much of the data, but where is the security? So Metplum places a strong emphasis on security. The first one is TLS 1.2 HTTPS. All communication between client and Metplum server is encrypted using TLS 1.2, ensuring that data is protected from interception or tampering. Then there is encryption at rest. Data stored in Metplum database and S3 bucket is encrypted at rest, providing the additional layer of security. So, Tulio, Mayuraj will can explain more about it.
All right. So guys, like you can also ask questions in the Q&A section. So if you have any questions, please ask them. We will get to them like as we are going through the discussion. So like Twilio. So first of all, in our automated voice call, we will need a way to communicate as well as create and like monitor calls as well as store the data from them. And we will also need a way to handle them, like handle those calls programmatically. So Twilio here provides a communication suite. Basically, it is um, a stack of all the APIs as well as different services that can be like used to create calls as well as like send messages, OTPs and stuff. So like Twilio provides like SDK for Node.js, Python, and like other languages, as well as there is an REST-based API as well for that. So we will be using like REST API in this example. Apart from that, Twilio has a programmable voice API. So what it basically does is it is a way to create automated calls as well as instruct like write those calls in a way that you can like add instructions to those calls. Like if you want that bot to say something or hear something or like do any kind of actions. So in the case of hearing or like recording or like transcribing input, Twilio supports a variety of models for that. So Twilio also provides like their own models, and then you can also add your own models if you want. Like, yep. Actually, next slide, please. Okay, so to instruct the Twilio's programmable voice API, Twilio has its own markup language. It's called TWML. It's like stands for Twilio markup language. So it basically is an XML that you will have to like use with certain verbs. Verbs are basically tags here. So let's just say like in response, there is the say verb. So this say will basically say anything that's enclosed in it. So here in this case, it will say hello world. And apart from that, there is this gather verb. So this gather verb is like really essential for this example because gather verb basically is the like way to record as well as not say record. It will help us like take the speech input from the user and then transcribe it through like Twilio's speech to text model. Apart from that, Gather also supports DTMF input, like the way you can dial while the call is going on, as well as there are different attributes to it. As like you can see, there is timeout that is like 3 seconds and number of digits you are like going to take as an input. Apart from that, you can also handle the stream voice data directly on your end. So for that, there is like this stream verb. So this stream verb basically sends audio chunks as a buffer to directly your WebSocket URL that you can provide in the URL attribute. So we will be using gather verb in our example because stream would take a lot of effort in like implementing our own model and engine to basically transcribe the speech data, and that is like out of scope for this demonstration. So yeah, next slide please. Okay, so other part of this demonstration is AWS Lambda. So as you guys have already seen that Metplum already supports like AWS Lambda based bots, but the problem with that is written around the wrapper of Matplum. So Matplum can only call that Lambda, not it cannot be called from outside. And problem, like the biggest problem we are facing here is that like it only responds in JSON as well as accepts input in JSON. But as you have seen like before, like Twilio ML needs an XML response, right? So for that, we will be using AWS Lambda here. So AWS Lambda is very easy to set up and get up and running with. So usually just need to sign in with the AWS console, define all your parameters in their environment variable section. And then once you have like created the uh, Lambda file, you can just create a API gateway, AWS API gateway, and point that to that like the Lambda function you just created. And to upload the code to your Lambda function, there should be an option to upload the code in a zip format. So that zip should include all the node modules if you are like using Node.js, or all the requirement libraries in it. Okay. Next slide, please. Okay, so we will be like demoing our implementation of it. So Akshay, can you like show the Health Connect application for this?
Yes,
Yeah.
sure. Invisible.
Yes. So this is
Okay.
Health Connect. This is like our like in-house app that is like basically a EHR integration hub. So it supports like all kinds of EHR integration like Epic, Cerner, and all the popular ones. Apart from that, there are other features as well. Like there are AI recipes to analyze patient data as well as disease information, and then there are other integrations like there is a feature to read HL7 messages as well as interpret them, as well as like it also supports various kind of bulk export and imports. So in these features, one is like Q-Connect AI, as you can see. So this is basically our like automated questionnaire feature. So what it basically does is like you can schedule or like start a questionnaire. So usually in hospitals, they have like different kinds of questionnaires that they need to ask to patients. So in this case, this like process takes a lot of time, like calling those patients and asking them like every single question. So this part like basically automates all of that. So this also reduces overhead in for doctors and admin stuff. So all right, we will create a demo call for you. So like Akshay, can you go ahead? Yeah. Right. So these are like mostly dummy patients with like demo data.
Okay. Should I start the call?
Just go back once. I think you clicked on another question here. Yep.
Yes, sir.
Just close the question.
Okay, just a second. Let's start it.
Yep.
Okay, let me select a few questions only so that I don't get much. Okay. So I'm starting the call, Neeraj.
All right. So I should receive the call. I will put it in speaker. Let's see. Okay. So I received the call.
Hi, Camille Lopez. This is Connect AI from Health Connect. Please answer the following questions. Have you missed any doses of your medication?
Okay, Akshay, let's just like select another patient. I think there was like a pending questionnaire in this, so that is causing the problem. Like
Okay, sure.
select a different patient for now.
Moshin.
That should work. Okay, so
Census. This is Connect AI from Health Connect. Please answer the following questions. Have you missed any doses of your medication in the last week?
no.
What is the most common reason you miss taking your medication?
There is none, no reason.
Take your medication at the prescribed time?
Yes, I do. So let's not wait for all the questions. That is the gist of it. So I should like update the progress now. So it's incomplete. You can also retry it. So yes, Akshay, like you can go back to PPT again. This was our internal product. Okay, so we will now discuss how it's built and like what's the process for it. So over to you, Akshay.
Sure. So the very first question comes, how we can create a programmable call from the Twilio. So as Mayuraj already mentioned about TreeML, which is an XML based language that allows you to control the flow of a call. You can use it to define what happens when the call is answered, such as what the patient is speaking. You can get that data from the tag called gather, and based on that you can answer. There are many other verbs or tags which we can use in 2ml. One is say, which plays a message to the caller. For example, you can use it to ask a question like, what is your current temperature? As we are already using in this feature, like that bot asks the patient questions about certain things and user answers that. Then there are few others like gather collects input from the caller either through speech or keyword process. There are multiple ways. We have taken from the speech. Then there is a start tag which initiates an action such as streaming audio, starting a recording. Second is which we need to set up is headers and parameters. This basically explain how to set up headers and parameters for making a programmable call to Twilio. Headers, there is authentication. Twilio requires an API for authentication. This is based in authorization header, as you can already see in the screen. There is another thing is content type, which is supposed to be application slash xww form URL encoded, because we are sending the data to Twilio. Few parameters are there like TUML. This is a script that defines the call flow. Then there is a two thing, which to which number we are calling, and there is a from the phone number from which the call is made. This must be mostly a Twilio number. Then there is third thing, API call execution. This basically explains how to execute the API call to Twilio. So there are few steps. First, we have to combine the headers and parameters into request object, then make an asynchronous post to request to Twilio's API, and then handle the response and pass the call data for further processing. Okay, over
so
to
we
you,
will be
Mehraj.
discussing, yeah, we will be discussing now how we are going to handle that callback from Twilio. So as you guys, as Akshay explained, once you create that call, Twilio will handle it from there, and it will initiate a call and then like record the input. And as you have seen, like we have passed like a WebSocket uh, webhook URL in that. So our Lambda functions URL will be that like webhook URL, and then it will be called once the Twilio records and transcribes the input. So first of all, we will be handling like the status of that call. So maybe like a patient doesn't pick up the call, or maybe it was busy. So in that case, we will be basically like just checking the Twilio's what is like call status, and then if it's in progress, then we will like proceed. And if it's like not in progress, if it's like stopped or something, we will just like update our questionnaire and then like respond with it. Next slide, please. Okay. So in case like when the call is in progress, we will have to first of all determine like if the questions answer that like the patient is giving is relevant or not. Like as like Manoj Kumar asked in like QA. So how are we going to deal with that irrelevant information if it is there? So here comes the ChatGPT. So we have a prompt for it. So it basically takes the question as well as the answer, and then it's tells us some like specific parameters about that response. So if that response is like a response or not, like first of all, maybe it's like they are asking like who's calling or like what is this. So for that, it will basically tell us like it's answer or a question. So in case of question, we will ChatGPT will also be like giving us a follow-up action as well as follow-up text, as you can see there. So we will be basically sending that follow-up text directly to the Twilio, and then it will say that word. So if a patient asks some question, like ChatGPT will help us answer those questions. Apart from that, if it's not like if it's relevant answer to that question, we will basically get a relevant info. Is like relevance will be high for that, as well as follow-up action and follow-up text will be null for that. So we can basically proceed that by taking it as an answer. One more thing ChatGPT does here, it's like errors are like it basically fixes all the errors in transcription. So sometimes like Twilio's like Twilio's models are not really like they're not like flawless. So sometimes there would be spelling mistakes or grammar mistakes that will be fixed by ChatGPT. So we are like it's a medical thing. So we have to store what response the patient has given exactly, as well as the interpreted response that ChatGPT provides us. So both will be stored with us. Okay, next slide. Yep. So now like yep. So now we have like gotten the response from ChatGPT, so we can store it as we want. So if it's a relevant answer, we will store it, and then we will look for the next question in the questionnaire object. And once we get that questionnaire object, we will like once we get that question object, we can encode it in like a response and then respond back to Twilio. So like Akshay, can you like go to like the next slide? Yep.
So, okay. So it was mostly all about the backend part. Let's talk about now front end, like how we are executing the front end part, how things are real time we are getting the data. So we have used WebSockets. So WebSockets allow for real time bidirectional communication between the client and server. In this case, we have established two WebSocket connection. First is questionnaire response, which provides us connection to receive real-time updates about the patient responses to the questionnaire, basically which patient is answering, then those responses are being shown in the UI, as we have already seen in the demo. The second connection which is being established is communication, which is used for general communication between the client and server. So there are few initial connection steps. The user starts a call through the UI. The application receives authentication token, and WebSocket connection are established using these tokens. So these two connection are mostly made during the initial connection. Then there is message flow. So message flow explains how real-time updates are processed and displayed in the UI. Let's break it down. The first is message flow steps, where the server sends update to the client via WebSocket connection, and the client receives these updates and process them, and the UI is updated in real time using React state management. As we can see in the code, that on message and send Q&A response is being used to stabilize a connection and provide a message flow. Then there is connection management. Connection management, mostly how WebSocket connections are managed to ensure stability and handle errors. We have used refs, which React provides for WebSocket connection. We have stored in refs so that it persists across renders in React application. Then we have also used error handling so that if connection fails, the system logs the error and can optionally attempt to reconnect. And then there is connection cleanup. When the connection is closed, the system performs cleanup tasks such as logging the closure and releasing resources. And these are the few codes which we have used to for the error purpose and like closing the connection.
Our discussion focused on like all the like how medical questionnaires like could be automated, and it's a very good use case for like all the call bots. And like as Akshay explained, how the MedPlum's architecture is based on like good principles, as well as they can be deployed on like AWS along with like different other platforms, and we demonstrated how we use like Twilio and ChatGPT to like create and program like this automated calls. So that was it. Will be if you have any like questions, like please put them in the questionnaire window. We will like be answering them now. Okay, so these are the current job openings we have in at Mindbowser. So if you want to join this amazing team, feel free to reach out. Yeah. So that would be all from my side. Have a great evening, guys. Yeah.